Okay. Once again, good morning. It is May 27th, and we have Jeremy Higgs from CAE with us to demonstrate Domo. Take it away, Jeremy.
Okay. All right, everyone. As you were told, I'm with CAE USA, and I work with Andra and Chaz. I'm I'm the data engineer for our Sherwood, Arkansas branch, and we do the analytics that we do is typically student satisfaction. We're branching into other realms such as performance, simulator performance. I'm sorry, but a lot of what we do right now is surveys, and so we're trying to gauge and measure all of our different training programs based on what the students are saying. And if anybody has been working with data and they're familiar with data, you will understand that open-ended comments and surveys are some of the toughest mind benders as far as data is concerned, because it's all unstructured. The open-ended comments are unstructured. So we really have to go through quite a bit of work to get to the point where we can see what is the student actually talking about. So as most of you know, probably all of you, there was a survey that I put out, I built for this, and Domo is our visualization. It's actually a full platform where we can clean data, transform data, and basically create new data sets off of a single source. So as you can see here, we have a what's called a Domo connector, and it connects automatically to the SurveyMonkey instance and the survey that I selected. I went and I think I have like 50 surveys on here, and so I had to go through and find the exact one that I created for this. And this starts our entire process. So the data, you can see it lives in here, and this is what SurveyMonkey data looks like if you happen to work in Domo and do the exports. But what we do is start here, and then we start doing transformations. Now, Domo has a feature called Magic ETL, and I'm going to go to that so that I can show you what our ETL looks like to transform. So we have an input data set and output data set, and now we're going to edit. So it's a drag and drop functionality. So you don't have to be a coder to do most anything that you want to do. You do have the option to throw in Python or R script, but you start, like I said, you start with an input, you name the input, and then you end with an output, and you name the output. And then everything in between is going to be your transformation layer. So there's text options, dates and numbers. You can do so many different transformations. I figured out that really with the surveys, pivot is one of the more important functions. And then I use the value mapper to do some, since you answered in words and text phrases, to get a quantitative number out of them, I did a replacement. So for each one of the columns that I created, what's data equals 1, familiar equals 2, and we work through that so that we can have some quantifiable data. And then go through, and there's a lot of redundant extra columns. So if you're creating a specific data set for an ETL, you really only want the columns that you need to do your analysis. And another thing that I use quite heavily is I'll try to do all of my math using Python script. Especially this mean function. We do a lot of averaging because we want to see what the average student says. So we use the mean function, and it automatically skips null values. You don't have to tell it. It goes through. And even this numeric only that I have that I've highlighted here, that is a default, but I always type it in just as a reminder that I want it looking only for numeric values. And we're doing axis tells it to calculate on the row. So really, if you mess with Python a little bit, you know that I'm casting a column right here, calling it overall average, and then I'm telling it how I want to populate. So And after all that is said and done, you end up with the output data set, and I can run a preview, or I can just cancel out of this and go to the data set. And this is what the data looks like after it's all been cleaned. It started out as, I believe, 84 rows, and now we've got it down to 11. So let me jump to the dashboard. Make sure that is not the one I wanted.
Hey, Jeremy.
Yes, sir.
That transformed data, when you said it started at 84 rows and it wound up at 11, was that from pivoting it and aggregating by something, or?
Yes, sir. Yes, sir. It's a yeah, we were at 84 rows, and we'll look at the actual data set, because that's how I learn. Just looking at the raw data set and figuring out kind of how it's structured.
What each row is what, yeah, it's
what each row is. And Domo transports their data rows over columns. I can't remember exactly how they describe it, but here you can see these are all the questions. And so this is every question for, let's see if I find a respondent ID for this respondent.
So questions times respondents equals row count.
Yes.
Gotcha. Okay.
So, and if they leave something blank, you can see that one of the things Domo does is it shows you where a repetition is. And since I've highlighted all these, there was no comment added. So it just emptied that out. It didn't send anything, so it doesn't show up. And then you go into the transformation in this lineage. There's that transformation layer. Let me show you that pivot function real quick, because it's actually, it can be done in Python, but I wanted to show the drag and drop. So this is, you're saying what you want it to look for, what you want to name the column, what you want it to look for in that column that you've identified here. And you have to tell it what identifies a row. So I did respondent ID, date start, and IP address, just to make sure that we were getting getting down to the most granular level we could for each response. And then you tell it where you want it to look for the response to put into this column. And for the open-ended questions like your employer, everybody could put whatever they wanted. So I didn't limit it down to any selection. So it put it in this questions answers text column, and it just fishes through there and finds all the information, populates it, and continues on down the line. You get to the script. And one of the things is you have a run preview button, so you can constantly test. Every time I change just a few characters, I will do a run preview just to make sure that I didn't break something. And it's just a very iterative process. Just take it one step at a time. And so I'll cancel out of that. And we can see, if we connect here, it'll tell you what cards we have connected to it. And this is all the cards that I've created to kind of look at the data the way it needs to be. And that is actually in the dashboard that I wanted to show you. This is my sandbox environment. So this is how you can visualize all of that survey data for Domo. And I've broken this out. These are all of our responses broken out by week. So you can see, and it shows you the average, the overall average of all the ratings. And basically where every question, it's average. So pretty average on the knowledge today. But what I can see from this, just from this chart, is from prior knowledge to expected knowledge, everybody is growing or feels like they are going to grow.
So that's telling you that pretty much everybody in the class is going to be disappointed because they have high expectations.
Well, I know we probably noticed that the last question, I put every answer the same. that master of all things data. That was an intentional to show you, I mean, and it's a hyper exaggeration, but for survey data, if there isn't a big enough gap between each level of a Likert based response, it can cause confusion and it can muddy your data and basically break everything. Honestly, that is a throw out question that would never serve a purpose in an analysis.
Yep.
Because there is no variability. And you can look at that as you get these giant data sets. And that's just really kind of the ways that we look at it. I really like trend lines. They show everything over time, and you can see these changes. And actually, you can see that people that answered on the 24th, they seemed like they were a little more optimistic about everything, even with the bad data. So their expectations are a little higher. People for prior knowledge, they on the 25th did not rate their knowledge very high. But that could just be one survey. And we can tell that by clicking on this. And yes, it is one survey. And you can see where they work. We have their employer. And if they fill this out, honestly, because quite honestly, it doesn't matter. Their age, they like hip hop, and they are expecting to grow. So, but you jump out of that, and that's kind of a drill down function, and I'll show you that in another, because drill downs are really important if you're trying to figure out some stuff. So I created this pie chart, and you'll notice that none of this is actually in any of the questions. There's another function inside that I'm going to show you inside Domo that allows you to create classifications. So we had 11 responses, and you can see the breakdown. And so for training, I decided I wanted to look at where the people worked that are involved in training. So we have 3 responses from ACDS, or 1 response from ACDS and 3 from CAE. So we can jump into those and see, and you just get to go down and actually see the actual data that supports it. And now one of the easy things about this, well, let me get back to where I wanted to be, is creating a card. You notice there's no comment, so I wanted to show you how to create a card, how we go about the process. And I clicked way too fast for that. I apologize. So I selected, I want to create a new card, and I tell it I want a visualization. We can do document cards and notebooks, but I work mostly in visualizations, and I want to use existing data since we already have it.
So a document card would be like a static text box that maybe like for labels or something like that.
Yeah, we some of our dashboards use them so that people can communicate back and forth with a group. We have a Domo user group that helps each other out, and we use notebook cards and document cards just to say, hey, how's everybody doing? We really like this. So I'll choose the data set, and it always pops up with an option. And this is not the option I want. I want to make a table because I want to look at comments. And to look at comments, you basically just drag your data wherever you want it to go. So if we want, and I'm not really worried about the any of the counts. So we'll just throw in some musical genre, and then, like I said, I want to see the comments. And that is how we build the comment table. And another thing that we can do, you can see that some people did not put comments in, so there's some null values. So we can throw in a filter.
There's a comment about the instructor for this course there.
Yes.
Jeremy, what did he say?
And we will get to that. So what I'm doing is I did it wrong. So I'm going to select that I do not want to see blanks just to clean everything up. And now all we see is actual values. and you can change the name. So I'm going to call it comments. And we save and close. All right, now let's get into scene. Drag this up into my demo area. Now let's look at these comments. All right, the instructor of this course is absolutely awesome. I can't imagine working with a finer professional. So,
well, whoever the female was that works at Spacely Sprockets must really it's me. I put that in there.
But yeah, that's all. And the thing about having a Domo connector, one of the things that I haven't done is I went ahead and filled one out this morning. This updated on a regular, it updates on a regular basis, but I went ahead and filled one out this morning. So I'm going to hit run now and tell it that I want it to reach out, talk to Domo or talk to SurveyMonkey, pull in the newest answers. And as it usually takes just a little bit to run, let me jump back into it. And it's telling me, okay, I'm working, be patient. And I'm sure you all have realized that patience is very important with data.
And this is a desktop app, and your data is, well, you're connecting to data in SurveyMonkey, which isn't necessarily like a local file, right?
Right. But it's reaching out to SurveyMonkey servers.
But once you get it into the desktop application, it's cranking on it on your desktop, right?
This is actually a cloud-based.
This is cloud. So you're on a browser right now? I'm not looking at an application.
Yeah. What I did is I just did full screen. That way I ain't sharing all my random bookmarks and things like that.
That's cool. So it's browser based. You don't need to install anything.
No, this is browser based. They do have a workbench that is set in Tampa at our country headquarters, or our department headquarters, I guess. So it's set there, and there's people that do workbench jobs, but most everybody is just in the web app. So that has run, and let's see. So it tells you last run a few seconds ago. We will jump in and look at the new data set, and it should say the same thing because it automatically runs. We'll check out last run a few seconds ago. Let's go back to the dashboard and we'll check that card, and it usually saves. There we go. Okay. So as you can see, there is one more that got added. And that summary number, it always throws a summary number, and I always forget to change it on the very first. But to change your summary numbers, let me do this. There we go. And if you don't want to do that, you can change or you don't want it to say distinct students, you can change it to comments. And now you are conveying as much information as possible. If you don't want this on, typically you can hide, but we are using the date group, so it won't let me do that. Now, the way we create, they call it beast modes. So I created the industries, if you remember correctly. I created a beast mode that is basically just a MySQL case statement. So you can read through here, and I may have gotten some of this wrong. If AHH is not Arkansas Heart Hospital, then you shouldn't be labeled in healthcare. But it was just assumptions that I made, and that's basically all you're doing whenever you're doing these kind of aggregations is saying, I think this is what this is. And if a new one comes in, I can just go in, add another line, and say, okay, everything's good now. Hit enter. You run the formula, save and close, and it's ready to operate. So we can actually turn and add this industry, put there at the first. And now we can look at that comments by industry. So, but that's really kind of the general process. A lot of what we do is MySQL based as far as beast modes. I do a lot of Python coding for data transformations in our ETL environment. And then we do all of our analysis based on the cards that we create. Does anybody have any questions about how any of this works? Okay. And this is just a tool. One of the things that I will tell you, we use Domo, and I use Domo. I was first introduced to it whenever I came to CAE, but the skills for data manipulation, data creation that you're learning today, they need to be tool agnostic, to where you can jump from Power BI, you can jump into Tableau, you can jump into any of the, I know of 100 data software packages that, SAS, RapidMiner, any tool that manipulates and transforms data, the skills you're learning are what you'll use to make it work.
That's I'm glad you said that. I honestly, guys, I did not pay Jeremy to say that. But you will see when I do a demo of Power BI, it's I mean the terminology is completely different. It's got a different look and feel. Same with Tableau Prep and Tableau, but the functionality is all there. The concept of importing data and then looking at it, transforming it, the ability to clean the data, to do like calculated columns or derived data from the data that you're using.
Right.
And you guys have seen a case statement. I don't know if you remember it from the MySQL lessons, but we did some conditional logic in a select statement.
Yeah, and really, I mean, they can be as simple. I do a lot of one lines, because if I'm just wanting to count each individual respondent ID, which gives me a good student count, it's just simple count, distinct, and it populates it for you. That's one of the things I do like, because I'm not a real good typer. So Domo just continuously fills in, so you can concatenate start date and click what you want, comma.
And you don't need the full select statement.
No,
but that is SQL syntax, right?
that it is. It's MySQL based syntax.
There you go.
So which is a little different than T-SQL and a little different than just straight SQL. So, it's really it's a functional thing. But once you understand the basic concepts of any of the SQL languages, you'll be able to translate to the next one and use them depending on what environment you're in. So, but if nobody has any other questions for me, I actually have a kind of a hard stop that I need to go to. Got a meeting coming up.
Well, I sure appreciate it, Jeremy. And
no problem.
This was perfect, because it's going to highlight, like you said, the functionality is universal. What you're trying to do is universal. It's just how the company goes about designing their user interface into that functionality is really the big difference.
Yeah, tools are tools.
Yeah.
You dig a hole with a shovel. It doesn't matter what shape it is.
All right, man. Thanks for coming in.
Yes, sir. Thank you for having me.
Okay. So why don't we, Aaron, were you going to do the Google Data Studio, or Laura, who did we decide was going to do a demo for us?
Yeah, I can do that.
All right.
And I apologize in advance if there's background noise. My daughter is sick, so she's one and she's in the background.
Oh, babies.
So just for an example, I brought my U.S. states data into Google Sheets. You don't have to use Google Sheets as your data source. You can use CSV files that are stored in the cloud somewhere. You can use a data warehouse like BigQuery. You can pull from Google Analytics, but I'm just going to use Google Sheets for this example. So I've got my medium household income on this sheet, and then over here I've got life expectancy by state. So this is it's all cloud-based, so it's just datastudio.google.com. I'm going to start with a blank report. Sorry, my internet and Zoom are just not good friends. Okay. So here's all the different data sources that you can pull in. I'm going to choose Google Sheets. Grab my median incomes.
And that just defaults to your own drive
Yeah.
for whatever you're logged into?
Yep. And you can also, if you have some sheets that are owned by somebody else but shared with you, you can grab those too.
Cool.
Then I'm going to grab life expectancy. So then something that's really cool with Data Studio is that you can do data blends, which is kind of like joining tables in SQL, but you don't have to know any SQL to do it. So I'm going to come in here and blend data and then I've got my median incomes. I'm going to add my life expectancy. And since they both have the state field, I'm going to join on the state column, pull in income and life expectancy. So then you can display it in the table that way. You can also, if you want to look at like a scatter plot to see, are these related? Are they correlated to each other? There's different chart types in here. I use time series quite often, but this doesn't have any dates in it. So I'm going to go with the scatter chart.
So did you copy the sheet?
I just copied this table.
Okay.
Just copied it down here. But you can also just insert a new chart.
Gotcha. So you copied it and then turned it from a table into a chart, like as a different object. Okay, yeah, this is all going to be real familiar. Keep going.
Yep, I'm just dragging. You can just click and drag. I'm going to make my x-axis the median income, and then the y-axis life expectancy. So then you can see the correlation there. You can go in here if you want this to kind of stretch out across the entire thing. You can come in here and change different settings, like the x-axis. Maybe you want it to start at 40,000, since it looks like that's kind of where this data starts. You can do log scale if you want. You can do trend lines. And then another cool thing you can do is you can do what's called calculated fields. So I'm just going to add a scorecard in here. If you want to take like the average household income, you can come in and do create field, and then you can do any kind of SQL query. It's not really SQL, I'm not sure what language it is, but it's very similar. So you can do case when statements, you can do average You change the type to a currency. So then you got your average. You want to give it a name. So you could do something even like if you wanted to round the life expectancy to the nearest, just down to no decimals. You could do round life expectancy 0. Get rid of that old one, but you can do all kinds of cool stuff with it. You can also add if you're working with dates, like a time series of some kind, you can add a date range control. You can also add like a drop down filter if you want to. Maybe you just want to look at certain states. Then when you go into view mode, you can just look at, uncheck them all and just choose, I don't know, just some random states. And then just like a Google Sheet or Google Doc, you can share this with people and they can just come to the direct link. They don't even have to have edit rights. They can just come into view mode and they can just play around with the filters. But yeah, that's
that last feature's, I don't know, wicked cool to me. So you can share it just like you do a Google Sheet or a Google Doc or a slide deck or anything like that. Mm-hmm. with no external service or that's the issue with Power BI is there's the Power BI service that you have to publish stuff to, and it's just not set up with anywhere near that kind of ease of sharing. I don't think Tableau's quite that easy. I mean, you can share the project file, but they've got to have the Tableau or Power BI desktop application installed. This is pretty cool.
Yeah. So the only requirement is that they have a Gmail account. But you can use your work email to create a Google account with your work email. So that's kind of what everybody at Waco, all of our work emails are also Google accounts.
Okay. Yeah, my acds.co account, my work account, that is a Gmail. We're we pay for them to host our office automation, so there was no conversion. We didn't have to associate it as a Gmail account. It's automatically there. Same with UCA, University of Central Arkansas. Those are all Gmail accounts, even though it's uca.edu, and they use Google everything for everything. Very good. Questions, guys? For about half of you are using this tool, so that's a great demo. Just another thing to learn. So much to learn. Okay, guys. No questions for Aaron. I appreciate it, Aaron. Thanks. That's informative. And I think that brings us right up close enough to first break time. So when we come back we'll go and take 20. When we come back at 9:30, okay, welcome back, guys. That last session when we went over lists and tuples and functions and modules and whatnot is still processing on YouTube. I haven't uploaded it yet. Just in case you were wanting to revisit that, I'll have that uploaded here this afternoon. All right, so Power BI. Let me kill some stuff here. We'll come back to Python, hopefully. So yeah, Power BI is going to look real familiar having gone, especially through Domo, the way Jeremy did the Domo demo. There's a workflow to Power BI that's very similar. So without further ado, I'll bring it up. It's a free download if you haven't downloaded it yet. Power BI, and the icon looks like a 3D bar chart looking thing. I should share my screen.
Hey, Don, I just want to let you know I made it. This is Chaz.
Hey, Chaz, thanks.
Hey.
Okay, so I'm going to share my screen and minimize my camera views and everything. Holler if I'm going too fast. Okay, so everybody getting a good view of Power BI desktop?
Yeah, I can see it.
All right. So yeah, a typical Microsoft application. So a lot of the functionality is going to seem a lot like Excel, but there are differences, and I'll try and highlight those as we go through. But I don't think any of you are necessarily using this. I think maybe Lindsay and Erica, this may be an option for you for your final project and at GSK in general. So we'll just do an overview of, grabbing some data, manipulating it, and creating what they call a data model, and then creating a report, which is basically a desktop. I don't think there's anything functionality wise, there's anything in here that I'm doing that you could not do in Excel. There's just a ton of overlap between these all these analytical products that we use. So first thing to do is to get some data. So up here, you see a few shortcuts. If you had SQL Server, which is their no kidding enterprise class relational database, you could grab stuff out of there. There are a lot of connectors to things like Oracle and MySQL. A lot of times they require a connector, a little piece of software, a driver to get to. So we'll keep it simple here. I'm going to open up an Excel file. And we are not going to open it from guitar stuff. Apparently I have some guitar stuff on my desktop. Let's see where that one was. No, oh, sorry. We're not doing Excel. We're doing Power BI. In my OneDrive, documents, under my coding stuff. That's where this is. I got a Power BI directory. And titles. Yeah, this is a sample Excel spreadsheet I got from a good course I'm taking on Pluralsight on Power BI. And the author does a great job of walking through the process. So what this is a IMDb International Movie Database dump from like 2014 to 2018 with a few different columns that we can play with here just to show how things work. So you click on your data source, it'll vary between as far as the exact steps, but for Excel, it's pretty straightforward. You just click on open and it chugs along for a little bit, creates a connection to that data. And it actually, Power BI is a little memory intensive. It's an application that's running on your computer, and the data that you pull in is in memory using Power BI. So if you're using larger data sets, it can take a minute to chug through what you're doing. So I believe the individual sheets inside of an Excel file are, you can choose all, some, or, well, not none, but one or more sheets. And for our demo, we're going to be working with table 3, which is our IMDb movies. Okay, so we'll load that up. Now, there was a button, load, creating connection in model, hourglass. So yeah, 2.7 megabytes. That's not a small table, not a small data set. So there we go. So we've imported it, and you can see it over here in fields. That we have some data in the report, but there's a workflow that seems to make a lot of sense, and it's real close to what Jeremy demonstrated in Domo. So the first thing is to bring up what Microsoft calls the Power Query Editor. Power Query is it's not just in the methodology, the terminology isn't just in Power BI. I'm pretty sure I've seen Power Query referred to in Excel as well. But so the first thing you're going to want to do in any data analysis project is look at your data and do some transformations. And I have a script so that I don't waste your time hunting and pecking. Okay, so we imported our file. The first step here, it opened a new window. I don't know if you can see that, but it opened a new window called the Power Query Editor. And this is where you can, without affecting that data file, without affecting titles.xls out on the hard drive, and that you are now dealing with a copy of that data within a Power BI project. So there's some stuff that you would that you would normally do, like look for columns you don't need, maybe. Some of these things are absolutely redundant, like end year. I mean, we've got the year it started. It didn't span years. And if you want to confirm, either in a spreadsheet or here, that there's really nothing meaningful in a column, you can drop it down and see we got nothing but /n. And in Power BI, it loads a few rows into buffer, but you can always hit load more and it grabs everything. And you can see that column is really just /n. So that end year doesn't do anything for us. So we'll say OK, and we can right click on end year and remove that from our data set. We've got a couple of different, we got redundant titles here. So there's not a real need for both of those. So we can get rid of original title, right click on that, hit remove. Got another kind of semi-redundant title type. That's movie, and we load more, and it's movie. So yeah, we don't need that in there. And a lot of the stuff you download, well, like you saw with the U.S. states project, you'll get columns that you don't need, and it just confuses your analytical software to have data that you don't need. So we will right click on that and get rid of title type. So that's one category of transformation that you might want to do in a work series. You can also filter rows. Like you may only want to deal with stuff from 2015 on. So inside of our data set that we are working with here in Power BI in this project, if I deselect 2014 and say OK, now all of a sudden we will see the filter icon, and we won't have any data from 2014. But I want to keep that because I'll need it in my bar chart I'm going to do here in a minute. So I'll put that back and say okay, and then poof, we see 2014 coming back. But you can do that, and there are conditional formatting, advanced kind of things that you could do with that format with that filter. If you click on number filters, this is where you can start to do some of the conditional kind of almost like programming. Don't show it if it's greater than this or less than that, and you can do multiples of this. So you can filter your data on that column based on some pretty complex rules. Okay, so that's that. Oh yeah, next step might be making, since it uses column names, you'll be using the column name to create, like the axis labels and data labels, and you'll be looking at that column name as an object. It should make sense. And sometimes you pull these data sets in, and there's 100 columns, and it'll be like C1, column C1, and you got to go look at the data description to figure out what that is. But for the sake of, I guess, compressing things, they make it these ridiculous column names. So yeah, you may want to change metadata, which is the data about your data types and names of columns and names of, well, things like names of our query. That's a Power BI ism, is they're calling this thing we're working on a query. Okay, we learned in SQL a query was a select statement with the where clause and order by and all that. So you just kind of got to be a little bit flexible. But here we can change the name. It's not table 3. That's not meaningful to us. So we can change it over here. Change it to say movies, and it changes over here. Or I believe, yeah, you can right click on it, and there's 2 or 3 different ways to do every single function depending on what you're comfortable with. So you can also right click on things and rename will be there. So yeah, we renamed our entire query movies. Tconst, not meaningful, and what that actually is. We will right click and we'll rename that to movie ID, something that actually might make sense for us. The primary and little lowercase primary title, that's not really too useful, so we'll change that to title. I'm just backspacing over, hitting enter. Start year, that's a little goofy looking, so rename that to release year. Runtime minutes, let's call that duration. And these yeah, these genres we're gonna fool with here in a minute. So we've gotten rid of some stuff. We've renamed some stuff, and over here, one thing I thought was a good functionality, a useful functionality, is that you can backtrack through major operations that you have completed on the data. If by chance you did something that you didn't like, you can back up to any one of these steps and undo them. Now but once you undo them, there's no reapply those steps. So you can't undo and redo and undo and redo. If I X'd on this renamed columns, I'd have to go back and rename them. So sometimes you want something that's a whole lot like this worksheet, but not exactly. So you make a copy of it and then go strip that other one down. So we can right click on this movies query. Again, that's the naming convention in Power BI. We right click on movies query and we copy it. Right click, copy. Okay. Did I not click on something? Maybe I need to apply my changes. Chugga, 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 chugga. Okay. I'll call you back. Okay, right click on the movies query and duplicate it. Duplicate. Did I not click on that? Anyway, well, there it is. So now we have an exact copy of movies, including all of the steps. So if you wanted to like make a copy of it and then back up, and then you've got one that you've completely messed with, but you want to go back to maybe the original or something like that, you still have these applied steps that you can goof with. But what I want to show you is this cool concept of splitting a column and unpivoting a column. See you will see this this genres column is what we're going to be focusing on next. You'll see this. This is not third normal form. Remember from our relational database design discussion, you don't want fields to repeat like this. You want to have a lookup link or something like that. This is not third normal form. So it's difficult to work with data when they have put multiple attributes inside of a single column. So we'll work on that in this next little bit here. So we've duplicated the query. So let's go ahead and rename it to what we're going to be working on, which is these genres. Okay, so I renamed it there, and now all I want are the genres. So I'm going to delete everything else. So I'm going to delete all I want are the ID and the genres. I'm sorry. So I want the movie ID and the genres. We'll show you what we'll do with that here in just a little bit. So I want to remove title. I want to remove release year. Don't care about duration. Don't care about the number of awards it was nominated for or won. Don't care about what it was nominated for, and I don't care about a binary yes no for best picture. Okay, so now we've stripped it down. So I for my naming convention, I really needed I just gotta put a capital G in there just because. So then over in movies now, we don't want this non-normalized column because we've already goofed with it over here in genres. So while I'm thinking about it, I'm going to go back over here and get rid of it in our movies query. So I'm going to remove. Okay. Now, in order to make the data so that it's more along the lines of relational design and pivotable. Remember the bank accounts creation exercise we went through with pivot table. So what you want is a movie ID and a unique genre. So we want one row for whatever the heck this first movie ID is, because it was only assigned to one genre of drama. But somebody thought that this movie ID here, 386697, was it's action and it's adventure and it's fantasy. So you've got what could be, 1, 2, 3, 4, we don't know. How many individual meaningful pieces of data are in there? Because right now, Power BI or Excel, that's just text. It's not data yet, really. It's thinking that there's a genre called action comedy, adventure comedy, fantasy, and we know that we want to look at things more granular to an actual genre. So you can do this. Pretty sure you can do it in Excel too. You click on a column, and you can say split column, and that will take a single column and split by a bunch of different options here. You can split by a number of characters. If by chance you have a a column that was like a fixed length thing where the first four characters were the first four characters of last name or something like that, and you wanted to get rid of that, an easy way to do it is splitting by a certain number of characters. But we want to split by a delimiter since they made it nice and clean with a comma in here. Split by delimiter comes up, and it defaults to comma, but there are other characters, and in fact you can, if it's split by like a I don't think dash is in here. Yeah, if it was a dash, like social security numbers maybe or something like that, or phone numbers, whatever. Anyway, yeah, you can split the column on what you want to split it on. And you can either grab just what's on the left. If that delimiter is in there more than one time, you can grab just what's on the left of the first time, what's on the right of the rightmost occurrence of that delimiter, or for us, since we're lucky and have this fairly clean data, we will split on every occurrence of a comma, and we'll find out how many individual attributes are in that column when it goes and creates these genre columns for you. Okay, so that's split on it. And now you can see some of them have one, genre 1 will be populated and the others will be null. Some of them will have genre 2 and 3, but none of them had a fourth genre. So that's why you only have genre .1, genre .2, and it automatically creates them. Okay, so that's split on column. Okay, so what we really want though is a row in this table that is with no duplicates. That is the movie ID and a genre, and that can repeat. It will repeat up to 3 times. But what we really want is movie ID and a genre, like that movie ID and action, and then we want that movie ID again, and then another row with adventure in it. So that's where we can unpivot is the name of the function according to Microsoft. So you can click on one column and then shift click on the other to get all 3 of them. And then we can right click on that group of columns and say unpivot columns. And it does what I said, but the unpivoting action creates the kind of something useful that you might use, but all we really want is this movie ID, which is repeating. You can see here this 386697 repeats 3 times. What we really just want is those unique genres. So I don't really need a column that shows me which attribute that was that unpivoted. You know what I mean? It's not really useful for us. And you'll see that once we get to the next step here. So we will single click on that, because if I right click on 2 columns and hit remove, it will remove both of them. So we're going to get rid of this attribute thing. So now all we have is a column for movie ID and a column for genre, but this value thing, it doesn't make any sense. So let's rename that to genres, plural. Hit enter. Okay, and there's other stuff, in transformation that you can do, is, getting rid of duplicates, and there's even like an error. I mean, if there's like goofy characters, there's a remove errors function in Power BI and other stuff. But let's look at both of our queries now that have related data, right? So we're building up this data set with related data. 956. Yeah, I'll get there. Okay, so let's look at movies. Go back and look at movies, and everything looks meaningful. I got rid of all my duplicate garbage. Actually, no, my naming convention is capital letter, so I'll rename awards to awards, and nominations I will rename to nominations. And there are different places and different ways in Power BI to like change the name of like one of these columns in one of these queries. And if you change it anywhere in that project, anywhere in the current file we're working on, they'll be reflected over in that other view. So it's pretty handy that way. So another thing you can do is get rid of goofy characters inside of a column. So we're on the movies query. So let's sort this title, sort this column in say descending order, and take a look. So we got these crazy European characters that you could decide to get rid of. But for example, say that's a whole lot of special character stuff. This is like an international movie database, and they did not transform in the database. They didn't transform it to our what do you call our alphabet? The Roman alphabet, the American alphabet, English alphabet. Anyway, yeah, there's all kinds of goofy characters in here that you may run into out there that you got to transform. So let's for example's sake, something fairly easy here. We're seeing a lot of movies that start with a pound sign. That doesn't seem to really be anything meaningful. So inside of a column, we've selected the column. We can replace values just like you can in any other software. So we want to find the pound sign and replace it with nothing. Just leave that blank. If there's a special character in there, you could do the same thing. So, okay. And you see, so there we go. And there's in the genres, there's a goofy thing in here. I want to say there's a /n that doesn't really do you any good. So let's replace in genres. Let's replace values /n with we'll call it unknown. That's an unknown genre, which is a little more meaningful and safe than some kind of weird special character string. Let's see what we got there. And if I drop down the filter button now, yes, I have gotten rid of /n in the genre column. Okay. Okay, so that is transforming data real quick. Lots of other stuff you could do, but that's taking a spreadsheet and doing some transformations to it so that it's a little more easy to use. And it gives me a convenient example in the data model view, which is the next workflow step that you would go to. So when you're working with query editor, you always got to close and apply, and this can take a little while, depending on what you're doing. And so we'll hit close and apply, and there we go. Yeah, pending changes. Whoop, hourglass, hourglass, hourglass. You'd think it was a Microsoft product. Okay. I need literally 15 seconds to go grab something to drink. I will be right back. Don't go anywhere. Okay, maybe 20 seconds, right? So, similarly to the way Jeremy showed you in Domo, these queries, these sheets that you're working on are in a data model for this project, and that data model is accessed via this little icon that's called model. So the query really becomes a table, like in a relational database management system, like we learned in MySQL. So and it automatically guesses relationships, particularly when you have column IDs and whatnot. So I want to drop these genres down, because in this data model, the stuff that we're doing is going to affect uh, a little icon next to each field or column, in a table. And right now, none of them are special. They're all just columns, so they don't have any of these icons. But like if you do a calculated field or a measure or a sign, like a key field, like in the movies database, I think if I right click on that, or there is a, where did I put it? I don't have to do it, but I found it and I wanted to do it for you guys. You can identify primary keys in here for a given table. There it is, key column. You click on the table itself, and you select the column with unique values, which is movie ID for us for the movies table. If I click on that, poof, you get what looks like a tiny icon for a driver's license, which is tells you that movie ID is the primary key for that table. And you'll see there's a couple of other informative icons that we'll be working with here. So there will be times apparently that a query won't be in your data model, but for us, they both are in here. And this is where, in this data model, is where you set things up so that the different visualizations, the charts and tables and other stuff that you would put on a dashboard can work their magic a little more clearly. So it automatically guessed this relationship thing here, but if I right click on it, I can delete that relationship if it was wrong, say. And I can always go back, working on it. I can always go back and just drag between key fields, and it will look at the data and assign a relationship. But you can edit that relationship if you double click on double click on the relationship bar. But I'm getting ahead of myself just a little bit. Yeah. If I double click on that relationship, it shows you the tables that are related and some sample data. The cardinality is correct, many to one. We'll come back to this cross-filtered direction. Sometimes you want that to be one way, and sometimes you want it to be both ways. And I can't remember if I got to come back to that or not. But anyway, yeah, cross-filter direction. So that's your relationship, and you can edit it, and inside of this dialog box. But it shows you the entity relationship diagram, and as this thing gets more complex, the lines get complex. I brought the Northwind database into Power BI from the access.mdb or whatever Access calls its file, and that's like 19 tables, and it got pretty complex pretty quick. So anyway, that's that data model, and you can hide columns that are things that you wouldn't necessarily want to use. So if by chance you want to hide things in the data model to avoid confusion, you just click on hide and report view. And we'll do that for movie ID too. Okay. And there are default actions on columns, and for this one it defaults to like the sum of the duration, and we want it to be like average duration. So let me I am losing my place. I'm trying to remember where you set the default the default action for these things, for these columns. Maybe it's over in the data view. Expand that out, duration. There we go. There's another view. That's your relationship, your data model, but then there's an actual data sheet view, and right now it's set to don't summarize, but we can change that to like the average of duration, so that, and this is by default when you go to use it in a graph or something, it does that automatically, but you can change it. Okay, next step. There are things you can add, a calculated column and a measure. A calculated column literally adds a column to the database, and it's there, it's real, it takes up memory, and a measure is something that's done dynamically, like at report generation. So there's slight differences in them in the way they're performed, but you use a Microsoft language. Have any of you heard of DAX expressions? Data, it's like data analysis expression. I've got the camera view turned off, so no one is saying yes. I've worked with those.
I don't think I've heard of it.
Thank you, Thomas. Anyway, yeah, DAX, data analysis expressions, is Microsoft's syntax for a lot of these functions and whatnot. And so you use a DAX expression, which is slightly different than Excel format. And then there's another language called M. So yeah, that's what I say. There's so many different tools to learn, so many different ways of doing things. But we can, let's see, got a few more minutes. We can create a calculated field. So we come over here. We're in the data sheet view. So we go over here to our movies query, and I'm going to click on a add column, new column. And that's where, when it pops up, it instantly assumes you're going to use a calculation, right? So it brings up these this DAX expression, which is just a lot like the formula bar in Excel. It just uses a slightly different format. So we want to create something. I thought this was pretty cool. A column called movie URL that is calculated based on a literal string. The URL is www.imdb.com/title/ and then we will concatenate that, and the concatenation character in DAX is the ampersand, and then the code, the operator to get it to look for column names is the bracket, square bracket. Whoop, not the curly bracket, the square bracket. So, and we want to concatenate that with movie ID, because that's the naming convention. Coincidentally, that's the naming convention at IMDb. Is it uses this literal string, and then it concatenates this TT6783970. And for every one of them, it'll be a meaningful URL. So, oh, and by default, it calls this new column, and inside the DAX expression is where you can rename it, or I think afterward, but I don't want to get off script because I'll be hunting and pecking. So we smack return on that, and we wind up with a useful URL column here, and that's a calculated field. And a calculation can be anything. We could divide awards by nominations to come up with a win ratio or anything. You know, literally any calculation that you can think of, you can do that way. And then a measure, like I said, is kind of dynamic. So we want to create a new measure, and you see the next to movie URL, that little icon, that tells you that it's a calculated field. And there's the different one for the key field in movie ID, and then duration. It shows that I changed the default action from don't summarize to now it's got a summary, but it's an average, not an actual sum. Anyway, but that's what those icons start to add, start to make sense for you above them. So we'll add a new measure, and then we'll be done with this, and we'll go on break. So we go to the ellipse, more options over here, and do a new measure. and now we have uh, measure equals. So we're going to call that new measure. We're going to call it movie count. And it's equal to, and you use these DAX expressions. There's functions. So you see it, and it's context sensitive. So it starts to guess. What happened? CO. If you kind of have an idea of what you're looking for, it does a pretty good job of guessing for you. COU, and I could count the number of blank entries. I could count the rows. Let's count the number of rows. So that's what we want to do. Count rows of, and then you need the table. Remember, once we moved from query to the data model, we call it a table. So there we go. So we use our movies table. Right click and hit enter, and it adds that that movie count as a measure. But it's dynamic, so it's not. Yeah, I'm just noticing this now, guys. It's not in your data model per se. It's something for the report view to generate at report time. That's what a measure. The difference between a measure and a calculation. Okay, so we're done with all of that. There you got our relationship here. And you can see the actual columns and start to goof with them. But then what we really want to do is graph something, right? So when we come back at 10:30, we'll draw some graphs and then finish up with that, go back, finish up that Python notebook, and we'll be done for the day. Let me stop sharing for a sec here. Come on. There it is. Okay. Questions or comments before we go on break? Hopefully it's not a huge yawner. Am I keeping it exciting?
Yes.
I could do interpretive dance, and then we rename a column, but we don't want to rename that row. Okay.
I think we should leave the dancing out.
Leave the dancing out.
Yeah.
Only guitar playing.
You're
That's
squelching. You're squelching my creativity. Okay. Only guitar playing. Roger.
it.
See you back at 10:30, 10:35.
Was that an option or?
It's an option.
Okay.
10:35.
10:35. Okay.
10:35. 15-minute break. See you back in a few. This meeting is being recorded. So back to the recording, back to Power BI. So let me share my screen again. Probably ought to share the whole thing. Just do the desktop in Power BI. See what you get there. Coming through? Build visuals with your data coming through?
Yep.
Cool. All right. So yeah, so we have these three icons over here. We have the data itself, um, the data model, which is just the relationships between the tables that are derived from the queries. But then we have the heart of the thing here. We got the report, which is what everybody sees. So you click on that part, and you get this blank canvas, and there are you'll see down here where on page one you can have as many pages as you need to to show data. So it's a lot like Excel, only a little less friendly. I don't know of a, like, bring in some data and insert a recommended pivot chart or insert a recommended chart. You kind of got to have an idea of what you want to do a little bit more. The first one on my script here is a table, because charts aren't the only thing. Sometimes if you're looking at it aggregated data, the text itself in a textual table um, can also be interesting. So we'll do that kind of of an object, an element, a report element, because you can have charts, you can have just regular static text boxes. You can throw an arrow shape on there. Pretty much anything you can do, like in Excel or PowerPoint or whatever. You can put on your canvas here. So we'll click on our one of our many types here. We got charts and line charts, bar charts and bubble charts and pie charts, and we got popcorn shrimp, baked shrimp, boiled shrimp, shrimp kebab. But we are going to pick table, and it just sticks it over there, a blank table object over in your on your canvas. But it's waiting for you to choose fields from your data model. So we want to show, say, title, URL, awards, and nominations. And like any other table, you can resize this to fit however you want to do it, to take up however much real estate you want. And there's just all kinds of formatting options. It's like any other powerful reporting tool. You just got to figure out what it is you're trying to do. You can size it bigger that way, that way. So that is a table object. Oh, and you can grab it by the line and move it around anywhere you want on your canvas here. Okay. So my next step, was to use part of this data, because just like in Excel, you can click on a chart and you can change the chart type. You can change the type of visualization, and everything about the fields and whatnot that you're using get applied to that other chart type. It tries to make sense out of the data, even though the kind of the formatting options might be a little bit different. So when you're moving between objects, you almost always have to, or between visualization types, you almost always have to do some kind of reformatting. So let's see, we want to highlight this table, and we want to copy it, and then we want to paste a new copy, which goes right on top and makes it really hard to see. But we wanted to drag that over here and do a little bit of work on it. So over here, I want to show just the awards. So let's see if I can do this without goofing it up. And we want to, I want to show the sum of awards. Yeah, which I've already, if I click on that field, I want to say sum over here up in the default behavior. I want to say I'm summing it. Okay. Okay. And next step is, yeah, this is where it got to that that relationship, bidirectional relationship thing. Remember, I was trying to figure out it's kind of goofing up because this cross filter direction, and I'd have to Google more about cross filter direction to see it. But this makes the relationship both directions of a movie ID to movie ID, and kind of fixes up the way your chart displays information. Okay. I think I missed a step. Clustered column chart. Clustered column chart. Oh, I see what I did wrong. Hang on a sec. Let me just click back on this table. I got this to work, I swear to God. Move some access to legend. Yeah, it's got it broken. I'm opening the project I was working on this morning where I got all this to work. Standby one. Okay. Yeah, after a lot of goofing around, this was. Can everybody see the actual dashboard now?
No.
No.
Not yet. Okay, let's see what we got here. Ah, try that one.
Yeah, I can see it
Got
now.
it now. Okay, so these are different kinds of these visualization objects that you can put in here. This was the table I started with, and I got it to work where I got the this one, the this chart here is just the movie count on the axis for that for a bar chart. The axis is kind of the axis here, right? Um, so the axis is I want to show a chart by release year, and then what I'm using for the value in that bar chart is the movie count. which was that measure. Remember that we created in the data model. So that shows you here movie count by year. Um, but there's other things you could do. I want to say by year you can um, look at average duration by year. Uh, and did you notice that cross chart pollination there? This is everything in the data, and this is a line chart using release year and the calculated average duration. See, our values now is average duration, but the line chart lights up for you. So we could turn that, I believe, into a clustered bar chart, and it would still pop right up. Yeah, just like you'd think. So depending on what you want to show, there's not enough difference in this scale, to use a bar chart for that visualization. Um, so a line chart's much more effective at showing the average number of minutes is what that is by release year. You see it going up and down. So that's another type of active visualization. Now, one thing that's bugging me here. Oh no, this is my old model. I didn't get rid of the /n in genre. And if you do a visualization, like I was saying earlier, if you change the data or the name or the metadata or any, inside of this Power BI project, it reflects everywhere. So I'm gonna test that. Here's a clustered bar chart by year that shows the different genres and the type and the number of awards they got. And we see drama, dark green, the dark green bar, it wins every year. But I don't like the fact that I got this /n for a genre. So I am gonna go back to transform data, all the way back to the query editor, like I did. This is a different file. I started from scratch to do the demo, and of course my training wheels fell off and I fell over and I started sucking my thumb. So I don't think you can see this. If I new shares the query editor, I think you need to see the query. I'll just share the whole screen. So we're back to query editor mode now, right? You can see that? Did I share my screen effectively? Okay, cool. So we're going back to the query editor, and I want to say we got a goofy genre here. Yeah, we got this /n genre that I fixed in the demo, but I failed to fix when I was getting all the way to the end this morning. So this is a different project, all the same data, all the same everything, but it's a different file. So let me get rid of that /n here in the Power Query editor. So I'm going to go back and replace the /n with nothing. And when I drop that down, no more /n. Okay, that's good. Okay. And then in the Power Query editor, you got to close and apply, which is what makes it crank. Go through everything, recalculate, throughout the entire project. So it's got to go find everywhere that might have any effect at all and refresh everything. Bam! No more /n genre. So that's interesting. That it automatically refreshes. And then we did another thing here that I thought was interesting is when we clicked on one of these years, we kind of got some cross object interaction. So yeah, since it's one data point, since it's yeah, there's only one average duration for 2018, so you get this one data point here. But this is a little more useful. It highlights, so we're looking at gosh, there were 11,000 movies, and here's the awards by uh, by genre down here for each year. And if you just move through and get your mouse pointer on each one, you get a tooltip that shows that, and you can turn on or off. You see what's going on in that black box. You can turn on what's going on in there in this tooltips field. There's so much you can do. But if you just go back to the and click anywhere in the blank canvas. Hello. I'm trying to unselect 2018. There we go. Takes a minute, man. Takes some cranking. So yeah, there's table objects, and you can I don't know what would happen. You can turn this table here into a chart. Let's try a bar chart and see what happens. Clustered column chart. I think it'll freak out. Yeah, it doesn't even know what to do. And that's where the moving things around between um, the axis fields and and values lets you shape actually what's in the chart. But let's go back to table, which makes sense. So like on this one, we let's see if I can't change something or add something a little bit different, because there's for a line chart, you've got release year. Maybe we want to contrast another variable on here. So we could drop um, another variable onto the values field here. Let's see. I'm going off script, but that's okay. Let's see the number. What happened? What happened? Whoa, 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 whoa. I don't know what just happened. Control Z. Good grief. I don't know what I clicked on. Undo. uh, did I go to a different window maybe? Yeah. That's what I did. I clicked on that different project. Freak me out. What happened to all my work? So yeah, so here we are in fact, let me get rid of that one that I untitled one that I didn't get all the way through. Don't save. So here's back to the one I finished. So you could add something else to this chart. Let's what would make sense? Like so we've got the average duration by year. We could get maybe the count or the sum of awards by year. So we could sum all of these categories. These are broken down by category. Let's see what that would look like. Average duration. If we open up movies and click on awards for that one. Let's see. It moved it to legend. We don't want it there. We want it down here. Count of awards. There we go. So it's yeah, that's the problem with two variables on the same scale. You've got the count of awards in raw number and the duration in minutes. So yeah, but it can be done. So that's where you start to pull different fields um, into your values field here in Power BI, and that's how it generates everything. And then these are some static elements that like this is a text box. This is a rectangle, a rounded rectangle that you could make as big or as small as you want, and it covers things, right? So you want to send it to back, which I did. Send to back. There we go. So it's behind everything. If you had like, some people love the way, like a background, like a globe or something like that, or maybe the company logo. So that's how you do that. Is you can put static elements and send to back, just like you do in PowerPoint. Movie report here. This is a text box. You can use it to make labels or anything you want like that. This is an image. You can insert text boxes. You can use buttons that have actions like next page. Since we have multiple pages in the dashboard, and that's what those are used for. And shapes, like if you wanted to add an arrow or something like that to point at something. There's your arrow. And I want to say you should be able to rotate that thing. Anyway, like I said, going off script. There's all of these different things you can stick on dashboards. So it's like Excel. A lot of the functionality is Excel-like, as far as I can tell. But then there's not. Then it's next level as far as doing the data model and that sort of stuff. So there you go. So that's Power BI. Just a really rough run through what it looks like. There's different visualizations. One thing I was playing with for on behalf of Chaz and Andra was I added a word cloud. If you see this ellipse here, there are more visuals. They're like custom visuals um, that you can add. And one of them was a word cloud that will go out and count the occurrences. I thought maybe it'll count the occurrences of words in your text, and it makes the word in the middle bigger for the most common word in a book or in comments or in whatever. It's a little tricky to work with. I mean, Power BI still wants um, data to be in columns, so it's twitchy like that. But I was curious. Have you guys, Chaz, Andra, have you guys used a word cloud at all to show like the aggregate opinion in
Yeah,
your
we tried it in Domo with the student comments, but because those comments are so standardized, it's kind of hard to really make much out of it. It is kind of nice though for like if instructors are mentioned by the students, we can see which instructors mention the most, but
Sure.
other than that, it's kind of hard to work with.
Yeah, they're not great. I used one in my dissertation. I had, I don't know, 60 pages of interview transcript where people were answering my questions and talking about the subject, and I did a word cloud to show what they use. But there are stop words. You can list words that you want to factor out of the model. Let me show one here just in case.
Yeah, most of our trouble was with the inconsistency I'm talking about. Like some people will type out the same answer in different ways. So like using
Different language.
Mr. versus Mr. Dot or instructor, or there's different variations. But it's at least nice at a glance to see some commonalities.
Yeah, you guys have seen these things. They wind up uh, in the press and whatnot, and like if you if you asked people in a survey to in free form, what did you like about this course, and then you take 2,000 answers to that question, you'll start to see what words you'll see if it's suck, if it's great, if it's okay, whatever the words are that people are using to describe it, you'll start to see those. And then you can get rid of stop words, they're called in a word cloud model, like a, I, the, any of those sorts of words that might be skewing the actual results. But there is a word cloud object that you can, and it comes up on the desktop. I don't have data to put in it that it was cantankerous to work with. I took a file and changed it to text and did a whole bunch of translating last night, and I don't know why I didn't save it, but anyway, um, that might be something, if you're using textual data. It might be part of a story. It might be one page on a visualization, depending, on if it's useful. And I'm not talking just to Chaz and Andre here. I'm telling you, there's a whole lot of visualization types out there, and to include Python and R. And I haven't even messed with all these. I did play around with these maps, filled map object, and there's another one, a map here, and they are really cantankerous. You can kind of get an idea of like the states with their different levels of obesity or smoking or happiness or whatever. But I couldn't get the thing reliably to like draw lines around the state, and you'd want it to be like a color code, you know what I mean, where like what one like light blue is nobody smokes and dark blue is everybody smokes, or something to that effect. But it was just a little cantankerous to work with, and I tried for, I don't know, an hour or so. It's just one of those, it's a powerful tool. They're sensitive to every little change, so you really got to know what you're doing. But there it is, Microsoft Power BI. So I don't know, guys. This course is so challenging for me to choose tools, um, and even from the same provider, like, if we went all in with Microsoft, there's analytical tools on Azure Cloud. You don't have to use these desktop applications like Excel, or we could do it all Google. We could use Google Sheets for the introductory stuff, data wrangling and basic charts, and all the kind of, the formulas. It does all that sort of stuff. And then, like you guys were showing me today, um, we could um, move from Google Sheets over into Data Studio, and then on Google Cloud Platform, there's machine learning and whatnot that you could then feed that data into, maybe that you don't want to necessarily do visualization with, but you want to actually do some clustering analysis or classifiers or whatever. So we could do this as an all Google stack sort of thing. It's tough to know what to choose from, and it seems to be changing pretty rapidly. I don't think anybody last summer mentioned Google Data Studio, and now literally half the class is using Google Data Studio. Um, so anyway, there you go. There's lots of tools, but what Jeremy say? You dig a hole with a shovel. As long as you know how to use a shovel, you'd probably use one if somebody hands you a slightly different shovel. So, okay, guys, 11:09. Let's take real short one. Take 5. Um, so 11:15. We can pull up. Go ahead and run Jupyter Notebooks and pull up that notebook number 10 that we were using, tuples and lists, and we'll finish that out. We were almost done. Pull that up and we'll get back together at 11:15. This being is meeting recorded. Okay, so we're back to finish up number 10 and make sure that everybody's okay with Python. I think what I would like to do is assign some more brain teasers for over the break, if and when you can get to them. Hopefully, when you can get to them, so that you're even stronger with Python. Because when we can, our next class meeting is June 8th with Mike Ellis, professor at UCA, and we'll be talking about pandas and no kidding data analysis. You've been learning coding, and I think Jeremy's demo showed that coding and understanding the whole idea of passing parameters and functions and syntax and whatnot. You can't get away from it. So the more examples you have of it in your head, the more familiar, the less um, trouble you'll have picking up these different tools, because you'll start to see how similar everything is. Okay, so real quick, I am not sharing my screen, correct?
Correct.
Correct. Thank you. I'm gonna save my movie demo project and share my Chrome tab. Share my Chrome tab. Okay. So I believe, correct me if I'm wrong, when we left off, we were doing this insert statement, right? And we were talking about the insert method. We typed in movies dot, and we saw this pick list of functionality associated with movies, because movies is a list object. The template to create an object is called a class. You might have heard programmers talking about, getting all of their base classes correct for an application. So that's how programming works. Is you create a thing called a class, and for this one, it's a class of list. And then each time you need a list object, you use that template. And part of that template, part of that class description, are methods, are things that you can do to an object of that class. And yeah, index is one of them. Goes out and finds the index value of the first occurrence of the blob. Did we run that? I don't know if we ran that. It doesn't look like I ran mine. Did we get there yet? Or is that where we left off? Somebody talk to me.
I think we left off in
Did we leave off in where I've got run number 26?
I don't think so. I think it was before that.
Before that, okay.
I want to say somewhere around right at the top of list methods.
I know I did this one.
Maybe.
Yeah, I know I did this one. Where we found, I typed in it and it found it, because I'd used some other nonsense beforehand. So I know I did that one. And I remember getting to this, if you don't know what an object is or not, say so now so I can thoroughly confuse you. Which I think was safe to assume that we've got folks that aren't rock solid on object-oriented programming. So I made my little speech. That's how object-oriented programming works. There's a template written in code out there for a thing called a list, and it's got certain behaviors and certain attributes, and when you create a template, a class template, that lets you create one of them. If you create something from that template, it's called an object. So that's the difference between an object and a class. The class describes how every list that we create, whether it's movies or student numbers or employee or whatever, those are all of the objects of the same class. So they all have the same behaviors and whatnot. They all act according to the same rules because they were created from that same template. So let's pick up here with movies. Did everybody type in movies and then hit tab? Something's going on here. Oh, I'm gonna have to go back and rerun everything from the beginning. Oh, because this is a brand new day, guys. This is a brand new day. I haven't run any of this stuff before, so none of these things exist. Even though it's got one next to it, it doesn't go back and create this stuff in memory. So hang on, let's. I think I'm gonna have to, and you will too, to make sure that we're getting all nice and caught up. Run. We could do run all, but I don't want you or run above. But I'm going to run them all independently to make sure I don't have any errors. And you guys do the same thing. I'm just going code cell by code cell and running them all to make sure that anything we had been depending on is refreshed in memory. So I'm up to number 7. Everything seems to be working okay. 8. Number 9 works okay. 11. And then it jumped to 14. I must have ran that one a few times. 12 looks all right. 13. Then we got it to list slicing. That was where we did a whole bunch of, remember the colon notation when you want to pull certain members of a list out. Run. And then when you want to check to see if something is in a list, if a value is in the list, the in operator. Enter a movie. So I'm caught up. So I've run everything before. So I'm up to what will be cell execution number 16 when I'm done here. So I typed in something random and it didn't work out for me. Bring it on. Not found. And when I run it again and I type in it, I found it. Okay. So then we get to the description of methods, which I think we're good now. I think well, I'm gonna keep going from here. So there is a method associated with the list class called append that just sticks a value on at the end, and we want to run that, and it adds Spartacus to the end of the list. But now, if I type in from scratch movies.tab, there we go. We get this pick list. Those are all of the methods associated with the list class because movies is a list object. I don't know what they all do. I probably told you that last time. Let's do movies.count. And I think every method's got to have a parenthesis at the end. Let's see what that does. Count takes one argument. Yeah, I'm going off script. Movies. I would assume that's what that does. Let's use the help. Oh, this is something I never showed you. Run. If you put a question mark, it's counting the number of occurrences of a value inside, not the size. It's len or whatever is the what's the one that returns the size of the list? Was it len or anybody remember? Seems I thought there was or was it a function that you send a list to? Len of a list. Anybody remember how? Because this is kind of a critical thing to understand. Sometimes you will send a list to a function that returns a value, and sometimes you got to. It's just by experience. Sometimes it's a method associated with that class of object. Does anybody remember how to find the number of elements in a list? I'm going back. Anyone? I'm trying to remember. It might be the len function. It was in this notebook, I want to say. I'm blanking here, guys. There's got to be a way to find out the number of items in a list.
Yeah, it's on number.
Or is it?
It's on number 4. Did I flash past it? Well, that's the for loop. Which one? I'm not seeing what you're pointing at me. I'm being blind here, Laura. Which?
For me, it's 13. It's len parentheses, and then you put the name of the list.
It is. So it's a function that you pass the list object to, as opposed to a method. See, that's to me one of the frustrating things about Python is that they can be implemented in either way. You could do a movies.len, with no parameters that would return that. But anyway, but we don't. So I'm trying to think of what other. I was just goofing around here, going off script. So count takes a string literal. So how many times is the blob in that list? Is that what I'm? Yes. There you go. So count counts the number of occurrences of something in a list, which can be useful. And then the next cell finds the first occurrence of that and returns the number of the index. So the blob was in cell 1, which remember is actually the second cell because it's 0 based. There we go. And then this next, which just does a bunch of, uses the insert method to stick at these locations, stick in a new element into the list. So at index 3, we're going to insert Ben. Index 97 sticks it at the end, and each of these subsequent print statements shows you what it did. If you give the insert method something beyond the list, I think this we might have covered this with another method, but yeah, you give it something that's before the end, it sticks it at the end. You give it something that's before the beginning, it sticks it at the beginning. And if you give it an M, what do you call it? A illegal negative index, it sticks it at the beginning. So Superman went to the beginning here. So now we've got right now, as of the execution, actually I didn't execute that cell. Run 23. So right now we've got a bunch of junk added to our movies list, including duplicate entries for it. And then here's another method that doesn't take a parameter, or there's no mandatory parameter, but it will sort the list, and then it actually changes the data. It doesn't just display the sorted value. It actually sorts the list. So we'll run this, and then reverse does the opposite. Reverses all elements. And because there's always more than one way to skin a cat, if you sort and say reverse equals true, it reverses it. So we'll see with these 3 print statements, the movies object in alphabetical order forward, alphabetical order backwards, and then again, alphabetical order backwards. So there we go. And it actually sorted it. It's actually persisted. So The remove. Oh yeah, yeah. Pulls out. Remove is another method. Pulls out the first occurrence that it finds. We run that, and we will see Star Wars, which is in there one time. So it'll remove that. Sure enough, pulled it right out of the middle. Yeah, here we go. Mike is such a good teacher. So the previous were methods of the object. So we use those, so we said movies dot insert or movies dot count, but there are functions like the delete function will delete what is at index 2, which is the exact same thing as the remove method. So, I mean, there's just, you just kind of got to get used to what you're going to do, or, there, but I guess it's good to have more than one way of doing something, but it sure makes it hard to remember how it is that you want to do it. So we will print movies out, and then we will delete the one at index 2, which is actually the third one, and it's in reverse order. So 1, 2. So we should get rid of Superman on this one if we run it. Kablam! Got rid of Superman. Yeah, min and max. These are functions that take a list object as a parameter. Min, max, sum of these different lists. And we can copy a list. Now we talked about that. Didn't we get into that whole pass by reference, pass by value? We got into that last time, didn't we? Yeah, we've been here before, because we were talking about if you just say films equals movies and then you modify movies, you also modify films. Yeah, we've been here. Is that coming back now? Anyone?
Yes.
Yes. I thought we'd been there, but let's run them just to make sure that we don't have any code dependencies. 526, 27, 28, 29. I think I left off here. 28. Yeah, these are just ways to make sure that you're not just creating. It's called a pointer. A pointer to something in memory is a very little thing. It's a memory address, which is tiny. Like I don't know, it could be what like 8 bytes, 16 bytes, whatever the computer's word size is. As opposed to copying the entire list, no kidding, the data which could be, a megabyte or whatever, 20 megabytes, to make a fresh copy of the data, having a pointer to it is a lot smaller. And that's why we use pointers for some things, but that's pretty advanced title, or pretty advanced topic. Okay, so we did this. We'll do it again. Yeah, it doesn't take effect to we didn't add anything. We didn't add get out to films. We added it to movies, but yet films is a pointer to movies, so you see it when you've got that there. When you do it that way. That's why when you copy a list, copy the items directly. Okay. And I think here we're getting to uncharted territory. Nothing's executed. Yeah, I think we're at uncharted territory now. Totals and averages. So what are we going to do here? We're going to walk through the loop. Yeah. So we just we're using this value as our loop counter to go through student numbers, and right here we've reinstituted student numbers with 1, 2, 3, 4, 5, 6 members. So it's going to loop through 6 times, and starting at 0, it's going to add each student number to total. So it's going to add 1,203.45, to total. And then it's going to count the number of times it's gone through the loop by incrementing counter by 1 each time inside this for loop. So that makes sense. And then we divide the total by the times we went through. Your accumulated total divided by the total by the number of items, right, is your average. And we print that out. That's pretty straightforward. Okay. Okay, and this one just loops through the days of the week and just does a really simple tally and prints it out. So you can run that and just type in some dummy data. And at the end, I have entered 282 for total sales. So that's a way to loop through a list and get the list to make a meaningful display for you. Remember the I goes through and the number of times in range here, 6 times, so which is dangerous. Or I'm sorry, 7. Dangerous. I don't know. I mean, there's only 7 days in the week. I get it, but seeing a thing that could possibly go if the length of the list changes is just a little dangerous. But anyway, it works. So there's when you guys are doing programming exercises, I hope you are not trying to just do them blank from memory, because I'm providing these notebooks as something for me to walk through, a script to make sure I don't miss anything, but also code examples for you guys to use. So, if you're creating a for loop, from your own memory, good on you. But I cut and paste code and change it to what I need all the time. You know what I mean? I just have a hard time remembering the syntax for this stuff. So here's a little bit of file manipulation, and we can talk about this, but only enough that you guys are okay with working with files for pandas, because you'll be using comma separated values, CSV files, to read data into pandas. So this is the Python syntax for working with a file, which is something that that you do frequently, but not terribly often, depending on the nature of your notebooks and whatnot. So anyway, this opens movies.writelines.txt for output, because you've told it this W here, and you've called it out file, which is a file object, which will then have methods, right? And writelines is one of those methods. So you'll write movies to this file, movies.writelines, movie_writelines.txt. So let me pop over to my navigator. If I change tabs, can you guys still see it? Or are you still seeing lists and tuples, or are you seeing my navigator view now?
Your new tab.
Say it again.
We can see it.
You can see the navigator.
Yes.
Okay, that will find not just notebooks, but it finds files and whatnot too. And I am in my notebooks directory. So if you don't give it a path, it'll open the file in the local directory, which we're working from my notebooks directory. So let me see what I got down here. I don't know if I got that or not. What was it called? Movies underscore right lines dot text. I don't see that from a previous goofing around with it. Let me get down to, I got it here. Let me delete it because I've done this before. So if I select that one and then hit trash can, yes, I want to permanently delete it. Okay, so I don't have any more than you do. I don't have movies underscore right line. So if I go back to my code and I run that file, we're going to write the list called movies out to out file. And then closing is an elegant way to close out a file, as opposed to, like, when you're working on something like in Word and your power goes out and it like corrupts the file. This is Python's elegant way of closing out a file so that you don't have corruption issues. So let's run this one. And it didn't do anything, did it? Or did it? If we go back to my Explorer, movies, right lines. Let's see what that looked like. Robocall. So it wrote it out, but there's no carriage return line feed, or there's no it wrote it out, but there's no like hitting enter to make it go to the next line. There's no new line character. So there you go. All of them are all concatenated together, which I think we satisfy in the next. And you don't have to close and exit a text file. It's not like a notebook file, but it is handy that you can look at non-notebooks in that navigator. So this next one, we want to add the new line character, and that's where we are using a different method. We're using write, and we're concatenating a new line character. We're starting a new file, which I'll go back over here and get rid of because I have from past experience. So I'm deleting my movies. Yes, I want to delete movies.txt. So if you run this next one, it should create movies.txt for write, and then write out. Remember, the loop counter item returns what is in the list movies. It doesn't go 1, 2, 3, 4, 5. It returns the actual element in the list. So we're going to write out the list element, which is in the item variable, and a new line character. And then we're going to close our movies object and move on. If you are saving numbers, convert them to strings as you write them. Okay. So number 2.text. I guess I'll get rid of that one too. 2.text. Okay. Yeah, it's just converting. I see now. We're just converting what look like integers and what Python will dynamically type as integers from student numbers, and we're just converting them to strings and adding the new line character. So let's run that one. And we should wind up with a better looking movies file and a good looking student num2.txt file. When we go back to explore, we're looking for movies and student, no, not two. So we go down here to movies .txt, and yeah, that new line character puts each element of the list on its own line. And then we had student numbers 2. That's new. And yeah, converts them to a nice string and puts a new line character. So that's writing to a file. And of course, and this is, it's like back in the day, did a whole lot of reading and writing from files, whether it was data or I don't know, just did a whole lot of file manipulation. I don't know that I'm used to doing it as a programmer anymore, but it's a critical part of it. So reading text file contents to a list. Yeah, you guys don't have this, but I'll run it for you, and then I'm gonna quit. I'm drying out. We need to do these last couple. Yeah, no, we can't quit yet. Okay, so reading text file contents to a list. Let's go look at numbers.txt, and this is something you all need to have. I don't think we've used it yet, but at the same level as your notebooks directory, you need to have a data directory so that the notation that I'm using will work. And all of the pandas stuff that we'll be doing uses data files that are in a data directory that is at the same level in the hierarchy as notebooks. So if I go into data, this is where keep all that, and generally speaking, I don't like to ever overwrite data. I like to keep the input data pristine. Some people will goof with that, but I don't know. Numbers.txt. So we got an integer and positive float, a negative integer, a positive integer, some other floating point stuff. We got different different significant digits. So that's our input file is numbers.txt in my data directory. So that's what open for read is what that R parameter. This R in front of the text string just allows it to read this text string correctly. So it's /data means go up one directory and then go down into the data directory and use numbers.txt. So we're opening that file I just showed you with those, 5 or 6 numbers. And we're opening an in file. I've seen I file. I mean, it's just kind of a naming convention. So we're opening a file object called in file. And then there's a file object method called read lines, the exact opposite of writing. So we're going to read lines into results. And read lines automatically iterates through the file without any, like if you're used to programming old school, you have to go through a file line by line and in some sort of a loop, like while not end of file, do this stuff. But the read lines method does that for you so that you don't have to iterate through it. And since it automatically iterates, it's gonna create a list type by default. So results is going to be a list. And then we close the file elegantly, print out those numbers in results. And let's see, what are we? Don's comment, don't know why this is commented, but float conversion still seems to work, even with the new line character, works with or without. For some reason, that had been commented out, but we'll see. Not really sure what it is. That's not a meaningful enough comment. Why did I comment that out? Okay, it was a year ago. Let's go. So we'll run this and print the results, and then we'll go through a for loop where we're changing each one to floating point and then printing it out again. So even those integers are going to look like floating point the second time we run this, I think. Let's use it. Let's run it and see what happens. Sure enough. Yeah, I guess when I got the notebook from Mike, he had not run this. He had commented this line out, and I don't think you need it. I think the second line works just fine. So we converted all of these input variables and their new line character. Maybe that's what the issue was. I don't know. Maybe if it comes up, we'll see. When you're dealing with data files in pandas, none of this matters. So I didn't really go into it too much because that's all I've ever really used file manipulation for. So it converts even your integer now. Remember that was a -8 all alone. It converts it to a floating point and prints it out appropriately. Okay, so a two-dimensional list. Yeah, a list of lists, which is going to be like a matrix. So if you have a list of lists so that each element in your list is a list, it looks like an Excel spreadsheet, right? And that's kind of what we're getting into with pandas. It looks like an Excel spreadsheet, which is, kind of what we're used to using. And there's all kinds of built-in methods and whatnot with pandas. But just out here in good old-fashioned Python, if you create a list of lists, you can get to individual elements in that matrix, right? Or like in Excel, it would be what, like cell D5 is row 5, column D. So this is the syntax in Python. But we will come back to this topic later because we're going to be doing rows and columns in pandas, and it's different. So don't sweat this too much. So now the last topic for the day is tuples, which are just lists that you can't change. It's literally and all the methods are the same except for ones that change the list. So we're going to create a tuple here. The significant difference here to tell Python it's a tuple and not a list is you use regular parentheses instead of square brackets. So that's the only difference. So films, same indexing, still zero based. So the index 1 is the second element. So Star Trek, there you go. Tuple looping. I love that guy. He's not nearly as goofy as you would think. from all the goofing around in the code. But for name in films, print, name, yeah, like we would think. Bam. So it loops through the tuple, just like it loops through a list. Now watch what happens, though. What happens? We're trying to append Superman to our tuple. What's going to happen, Thomas?
I don't know.
I don't either. I'm wondering if it's going to say, there's no such method, because it's a tuple object, and the first check would be whether or not there's an append method, because you shouldn't be able to append anything to a tuple because it's immutable. So that's what I would suspect, but it may tell you wrong data type for this method. So that's what both of these should error. Films 1 equals Superman. Yeah, this one you're trying to append Superman to the end, and this one you're trying to change Star Trek to Superman. Syntactically, that's what you're trying to do. But a tuple object has no attribute append. There you go. Yeah. There is no append method. So reading Python error messages can be a little tough. It certainly can. So what? If lists are so great, why do we need tuples? They're faster. You won't accidentally in code change the value of a tuple, which, depending on how complex your code is, you might accidentally change the wrong variable name. That keeps you from making that mistake in the code. And then there's some operations that are tuples. Like I want to say a row of data from Python is a tuple. You can convert it to a list so that you can goof with it and then write it back to the pandas data frame. But I want to say if you access that row, it is a tuple. And then of course, you can convert between them. Kablam. And well, that doesn't tell me much without the print statement. I mean, without the type command. So let me type of movies and the type of movie tuple. Is that gonna work? Does that look right? 1, 2, 3, 1, 2, 3. 1, 2, 3 left parens. 1, 2, 3 right parens. Let's see. Kablam. Yeah, list and tuple. So that proves that there's the different data types. So back to list. This reminds me of the penny trick in Sixth Sense when it goes from one hand to the next, and now I'm gonna put it back to the other hand. See, I'm magic. Without proving it. So there we go. Maybe I just got ahead of myself. Maybe I was just being sarcastic. Okay, so that's lists and tuples, and basic operations of all of them. Like I said, when we come back on June 8th, and we jump into pandas, it will be good for you to have done a little bit of programming with these things. So let me hit the internets and come up with some programming challenges, and I'll post them in the classroom, and it'll be Python problems 2. And we'll work on that between now and June 8th. And if you want to get together, I mean, we're not going to meeting next week. I thought I was going to wind up taking vacation, but it's not looking like it. Life intervened, and I'm basically, I might take a staycation for a day or two, but I'll be around. If you want to get together and work on these problems interactively with each other, please let me know. To include, after work, if that works better for you. You got my email, you got my phone number. Let me know. There was one other item of business. Oh, Thomas, I was in Florida when I invited you and Randall to talk about the final project, and it came out on the calendar as 4 o'clock Central. I invited you. You said 5 o'clock, and I invited you to 5 o'clock, but I was in the Eastern time zone when I did that. Is 4 o'clock okay for you and Randall?
I mean, it's okay for me. I'll check with him, but yeah, I figured it was something to that effect with the time zone and everything. So
Well,
I'll ask him.
I can move it to 5. I can move it to 5, but when I saw it go to 4 and you accepted, I was like, oh, good, because the earlier I'm done in the day, the better off I am. But I want to be accommodating to you guys.
Yeah, I mean, it would work fine for me. Like I said, I could check with him, and I'll shoot you an email.
Yes, please. Okay. Any questions or concerns other than need some practice? Going once, twice, thrice. Okay, guys. File, close, and halt. Yeah, Tuesday morning, June 8th, we get going with a library called Pandas, and you've seen what a library is. It's just more functionality that you bring in with an import statement. And I think it's a 1-day workshop. I think Mike will also do maybe a little bit of his graphing and analysis and that sort of stuff, not just slicing and dicing data with pandas. That's the other thing is you can do it. You can do everything I did in Power BI today. All of that, filtering by row, changing column names, changing data types of a column, changing the name of the file or whatever the parent thing is. You can do all of that. Search and replace for error for weird symbols or stuff inside of a data frame. You can do all that, and the real magic about Python to me isn't so much using Python or R interactively to do that. It works, but the real magic is if you have a data pipeline. That Python code will do all of that for you automatically every time, and it does it flawlessly, and it does it virtually instantaneously. So if there are steps like grabbing the data, changing the data, running some numbers and kicking that out to a file, or running a chart and saving that as an image, or anything that you can automate, once you get it working, man, poof, it's magic. So I mean, yeah, Python's cool to play with interactively like we are, but I don't know that I would use it more than I would use Excel or something else to just kind of comb through data like this. There are some libraries that make it more, that make a bigger difference. There are some scientific libraries that do analysis in front of you in real time that you wouldn't be able to do um, with Excel or Power BI, machine learning, those sorts of things, other stuff. So there's some merit there, but for just good old fashioned cranking through a data set, a CSV, yeah, Python's better for automating routine steps than maybe it is for interactive. Although it depends on your comfort level. There's lots of different kinds of shovels to dig that hole with. Just go pick your favorite kind of shovel. Okay, guys, since there are no questions for me, I'll wish you a happy Memorial Day weekend. and I'll see you on June 8th.
Thanks, Don. You too.
Memorial Day.
Have a good